All right, let's talk about some antenna stuff now. So this antenna is something I made about 11 years ago, 10, 11 years ago. It's a UHF antenna. It's one half of an egg beater style antenna, which is popular with folks that are into satellite operation. But in this case, rather than two sets of antenna elements that are fed out of phase, that works great for satellite. This is one plane antenna, so if you're aiming it this way, it's vertical polarization. You aim it that way, it's horizontal polarization. And what makes this antenna fairly interesting is at 2 meters, this functions as a third harmonic of the lower frequency band, so you gain the benefit of having a very small and compact directional antenna that will reduce the signal level, which is really handy if you're trying to find a hidden transmitter on 2 meters and you want to find where it is and not have a huge antenna. So this has been a real great little tool for me over the years with radio direction finding. In addition, it also works at UHF, which is its designed frequency. This one in particular is at 435.5. So right there in the satellite passband, makes a great downlink antenna on the SO50 satellite, makes a great uplink antenna on the AO91-92 satellites. So it serves a lot of dual purpose, both satellite, radio direction finding, and then even if you just want to connect it to an HT and hit distant repeaters, you can do that. I've strapped this to my backpack when I go on summits on the air and want to see how far I could send my UHF signal and not have to worry about a big antenna or something that's going to get broken, climbing up a mountain or something like that. So that's kind of the reason why this antenna exists. In terms of its electrical functionality, I'll start from the driven element, which is this rectangular part. So this technically is a full wave loop on UHF. It is fed inside this piece of PVC pipe with a 75 ohm piece of feed line. The reason why we're using 75 ohms inside here is that when you have a full wave loop and you feed it here in the center, represents about a 300 ohm impedance, compared to if you sever that and fed a feed line here, it gives you about a 50 ohm match. So that would be a little unwieldy, so that's why I did that. So full wave loop, 75 ohm, feeds into the B and C connector down here. And this element right here acts as a reflector. It is not electrically connected in any way to the driven element, like any beam. So this allows us to send the majority of the signals out that way, or to reduce signals coming from behind. So again, this works fantastic for both finding and sending signals. Sometimes it's easier to actually find a hidden transmitter by finding the null versus the peak of a signal. So that tells a little bit about this antenna. You'll see an article with some of the math behind this antenna if you'd like to make one of your own. You'll also note, if you're interested in antenna building projects, there's a larger version of this antenna, typically called the IO antenna, which combines both a 2 meter and 440 version, which is fairly popular amongst those that are interested in satellite and would prefer to build their own antenna rather than buy a commercial elk or arrow antenna. So that's this guy, and this also most recently served as inspiration behind another antenna. So this one right here, you'll notice, very similar design. This is made for the 900 megahertz band, which is shared. It both is home to amateur radio, 33 centimeters, as well as a number of other services, often known as ISM or industrial science and medical. So utility meters, and a lot of IoT devices also use 900 megahertz. This antenna is going to become part of a project that HVDN has been secretly working on over the past year, called HasViolet. So you'll see some more information about that coming in the near future. So let me give you the size comparison. Same math, but just scales downwards. So UHF compared to the 900 megahertz antenna, and then you can go one smaller. This one is for 1.2 gigahertz. So I could use that with the ICOM 1.2 gigahertz HT, and send my signals even further with an antenna like this. So hopefully that helps describe a little bit about some antenna toys here, and you'll see some future articles on the math and the mechanicals and the how to make or even purchase one of these from our upcoming store. So that's it for now.